Okay, in this video we'll be looking at significant figures, which is a way of specifying how precise a measurement is. Now when we work with decimals like this, we might think that to increase the accuracy of this decimal, we just need to take more and more decimal places. So the more decimal places we have, the more accurate we are, and in this case that is true. But when it comes to measurement, this isn't always true. See, if we ask someone how tall they are, they might say something like 1.6 meters, right? And we might then get the measuring tape and get a bit more precise and say, oh, they're actually 1.62 meters, okay? Or even 1.625 meters, okay? But does counting decimal places always mean we're getting more accurate? Well, no, okay, and here's a really stupid way we can demonstrate this. See, we currently have 3 decimal places, the 6, the 2, and the 5. But if we just switch to kilometers, we divide by 1,000, and suddenly we have 6 decimal places, right? It's 0.001625. But obviously the measurement hasn't changed one bit. We're just using a really dumb unit of measurement. We're describing how tall someone is in kilometers, and that's very silly, okay? But this does illustrate one thing. These zeros at the start of the number don't contribute to how precise or how accurate the measurement actually is. They just tell you it's a really small number. Okay, the real measurement actually starts at the 1. It's just the 1625 part of the number. So because of that, while there's all these decimal places with the zeros, not all of them are actually truly describing the measurement. Only these 4 digits, the 1, 6, 2, and 5, right? And so we say that this measurement has 4 significant figures. Okay, the zeros at the start are what we call insignificant, okay? While they are important for telling you that it's a really small number, they are not part of the actual measurement itself. Now, we encounter this idea when talking about really big numbers as well. So for example, we might say the population of Australia is right now about 26 million. Okay, that's 26 with 6 zeros at the end. And now at the time of making this video, the most recent census data from mid last year or something puts the population at somewhere around 25,739,256. And the Worldometer, again, as of making this video, puts the population live at something like 25,996,764. Okay. But if someone says the population's 26 million, well, we can only be sure about the accuracy of the 26, right? We only have 2 significant figures for sure here. But now if you rewind a bit or just remember that the Worldometer said it's actually something like 25996764 or something, this number's actually quite accurate. Okay, maybe more accurate than we might initially have thought. Okay, we're actually precise to, well, this level here with 4 significant figures, because that's how close we are. Okay, but see, if we didn't know the actual number and all we read was 26 million, we wouldn't know that. We would only be sure about the 2 and the 6 being accurate. And all those zeros at the end are just there to tell us that there are an awful lot of people in Australia. Okay, but the truth is, this is actually very close to the real number, and indeed it's very much within the realm of possibility that at some point in time, and by the looks of it, in the near future, from the time of making this video, there will be an instant at which there actually will be exactly 26 million people to the dot, right, in Australia, okay, and we never know. Okay, and so we're actually not sure how precise these zeros here are. Okay, it's safest normally to assume they're not accurate, but again, we can't be totally sure. And this is a problem we'll actually address in the next video, okay? But before we finish, I want to address a special case where we compare a measurement of 2 centimeters with a measurement of 2.0 centimeters, okay? Now, mathematically, these two are of course the same thing, but it's important to see that if we are reporting a measurement, we're actually communicating measurements that are quite different. So let me explain here, okay? On the left, if we just say 2 centimeters, I like to think of it as something being measured with a centimeter ruler, like this. Okay, you can't be sure exactly what led to this reported value of 2 centimeters, right? It could have actually been 1.8 centimeters, just rounded up to 2. Or it could even have been something like 2.4 centimeters, rounded down to 2. Okay, you don't know what sort of rounding error we're talking here. So indeed, the real length of whatever they were measuring could have been anywhere between 1.5 and 2.5 centimeters. And the reported value of 2 would still have been honest up to that rather loose level of accuracy. But if we say 2.0 centimeters on the right there, okay, it's like we're upgrading rulers. We're now using a more precise ruler. Okay, so let me explain again. If we get a bit closer, we could have all these measurements here, 1.6, 1.7, 1.8, and so on. Okay, but when we write 2.0, we are communicating that it cannot possibly be 2.1 rounded down, otherwise we could have just written 2.1 centimeters. Okay, and so of course it can't be 2.2, 2.3, 2.4 for the same reason, and going back the other way, it can't be 1.9, 1.8, 1.7, and so on, because if it were, we could have written that, but we didn't. Okay, the fact that we're writing 2.0 communicates that this sort of loose rounding has not taken place. It actually can't be any of these values here. So really, the actual measurement can only sit inside this tiny window here between 1.95 centimeters and 2.05 centimeters. And this sort of thinking with rounding and stuff should really remind you of a previous video on measurement errors and things like that, okay? This 2.0 centimeters is communicating a much smaller margin of error. And that means this 0 actually has a really important job. It communicates greater accuracy in measurement. And so that means this 0 is significant. Okay, so to sum up, significant figures are digits in a measurement that contribute to accuracy or precision in that measurement. Okay, the only insignificant digits would be zeros at the start of a number that just tell you it's a really small number, or possibly zeros at the end of a big whole number that just indicate a really big number. Okay, but even then we can't really be sure, like for the population thing. So again, we'll deal with that in the next video. Okay, so thanks for watching. See you then.